Hello and welcome to this video where we'll introduce the stages of the UiPath Automation Implementation Methodology Model. Upon completion, you'll be able to describe the different stages in the UiPath Automation Implementation Methodology Model, list the tasks that need to be carried out in each stage, identify the key practitioner roles involved throughout the implementation process, explain the main responsibilities of the roles typically involved throughout an implementation, and summarize the expected output of each stage. All set? Great, let's get started. In general, an automation project can become a reality through the collaborative and coordinated actions of a given group of professionals. The size of the group and the degree of involvement of each member can vary, but at the core, there's always the automation implementation team. This consists of solution architects, project managers, business analysts, automation developers, and infrastructure engineers. In mature companies, the members of the implementation team come from the Automation Center of Excellence, which is responsible for the planning, execution, and monitoring of the entire enterprise automation program. Depending on the nature of each automation initiative, the size and the structure of the team can be very different, just like the skill set and experience of the members selected. At the same time, every implementation requires close collaboration between members of the implementation team and the client team. Let's keep that in mind as we progress through the stages. The informal start of the project is when there's an automation opportunity with good potential. And the first stage in the implementation process is kickoff. At this stage, the key people involved are the infrastructure engineer, the solution architect, and the project manager. The purpose here is to lay out and align with the client team on the expectations of the project. At this stage, an early examination of the client's environment and infrastructure should be initiated, answering the basic questions. Do they already have test and development environments? Do they have test data? Can they create test cases? For projects involving multiple legal entities, it's essential to draft and sign off the Statement of Work, SOW. Another output of this stage is the establishment of a communication cadence between the teams and the completion of the client's readiness checklist. Another document to introduce here is the issue tracker. This document will be used to compile all issues throughout the project to enhance transparency. The issue tracker can be used for environment access issues, development roadblocks, user acceptance testing failures, or anything else that's impacting the progress of the implementation. When these outputs are complete, we can move on to the next stage, business case and technical validation. During the business case and technical validation stage, the potential automations are assessed for their business value, complexity, and feasibility. This is to validate estimated timelines and efforts required for successful delivery, as well as to get an idea of the return on investment. As part of this phase, the business analyst takes a more active role, along with the solution architect and project manager. Business analysts would validate the business case for the selected use cases for automation and the cost-benefit part of it. Here, solution architects are responsible for identifying the key complexity, technical dependencies, and access needed for themselves, the developers, and the robots. This includes any application used in the process and access to Studio and Orchestrator for developers. As the output of this stage, the team identifies or verifies the automation use case and confirms whether the use case aligns with initial estimation or contract expectations. Perfect! Now the next stage is process analysis. The key people involved in this phase are the solution architect, the project manager, and the business analyst. Here, the business analyst and the solution architect work together to analyze the chosen process in its as-is state and draft the process definition document. Using this analysis and based on the complexity of the process, they can determine the extent to which it can be automated. Next, they optimize the overall business flow of the as-is process into what's called the to-be process. At the end of this stage, the high-level to-be process must be created by the business analyst and the solution architect and agreed upon. The to-be process is what will be implemented. Next, the process definition document is filled in with the as-is and to-be processes. Once the PDD is completed and approved, the client team has the responsibility of coming up with the success criteria and the UAT test scenarios, which will be the basis of the UAT plan, drafted by the business analyst. The UAT plan is a document outlining the tests to be performed, as well as the logistics for how end-user testing will occur after development. The client team will ultimately be responsible for coming up with the scenarios and the data for the UAT plan, but the business analyst can assist with structuring the document depending on their level of experience. By the end of this stage, the UAT plan must be created and approved. Once the business requirements of a process are finalized, the solution design stage of the implementation process begins. The key role involved in this phase is the solution architect, taking help from the project manager and the automation developer. During this stage, the solution architect designs the future state flow and maps out the various modules to be developed to complete the automation. The application tracker is used to record access required by the developers to build the automation and for the automation to be run in UAT and production. Once a solution has been determined and fleshed out, the solution architect and automation developers work together to prepare the technical testing plan, which should encompass UAT scenarios, functional testing, and system integration testing. The outputs of this stage are the approved solution design document, completed application tracker, and completed technical testing plan. Collaboration between the solution architect, the project manager, and the automation developers also occurs during the next stage, development and testing. Here, the automation developers create the modules outlined in the design whiteboard using the PDD and SDD documents as references. The solution architect then reviews the code and automation developers make the necessary fixes to the code. The created modules are then tested individually to ensure that they run successfully in controlled test settings. This is called unit testing. Once completed, the developers further execute the technical testing plan. For functional testing, the goal is to confirm that large functions work independently. For system integration testing, an end-to-end test should be completed in an environment that mirrors how the automation runs in UAT and eventually production. Lastly, the developer should run all UAT test scenarios in that environment to confirm business expectations are met by the automation. With the growing importance of testing, test automation is a way in which this stage and the sub-stages can be executed more efficiently. As a result, the test automation engineer is a fast-growing role, so many centers of excellence are now including it. The outputs of this stage are the built automation with unit testing, integration testing, executed technical testing plan, and code review completed. Using these outputs, the developed automation solution is ready for the next step, namely user acceptance testing, UAT. The key people involved in this stage are the solution architect, the business analyst, the project manager, as well as the automation developers for bug fixing. The end user conducts UAT in coordination with the implementation team based on the UAT plan created and approved earlier. The bot in the pre-production environment runs all of the potential happy path and business exception scenarios. This is to ensure that the automation is performing per all agreed upon requirements. If there are any deviations from the expectations due to defects or bugs, the business analyst would log that and the automation developers would fix them. At this point, the developers create a runbook document template in collaboration with the solution architect. This document must contain relevant information on the system architecture, details on the production environment and instructions on how to operate the automation if necessary. It also includes detailed instructions to operations, IT, and the infrastructure team on how to proceed with deployment. If needed, the runbook document template can be further adjusted during hypercare. As a best practice, we highly recommend documenting the runbook template for every automation. Upon successful UAT testing, the client's team signs off on the automation implementation. Great! This brings us to the next stage, deployment and hypercare. The key people here are the solution architect, project manager, and automation developers. In this stage, the final process packages, libraries, and assets are migrated to the production environment. Then, they're set to run on production robots, which must have access to the production instances of all in-scope applications. Hypercare is a time of increased monitoring and support to ensure that any issues that arise are quickly identified and addressed. The goal of the hypercare phase is to ensure that the new system or release is stable and functioning as expected, and to resolve any issues that may come up during this initial period. Usually, hypercare entails daily sessions, where cases run in production are reviewed by the automation implementation team and process subject matter experts. If any errors or issues are found, they're promptly fixed and pushed to production. Companies with large automation programs would typically set up long-term automation support teams, which can be part of the Automation Center of Excellence or can be separate but maintain direct contact with the COE. During hypercare, knowledge transfer should be initiated by the automation implementation team towards the automation operations team and the long-term automation support team. This will enable them to take over the automation management confidently. By the end of this stage, the production bug fixes are completed and the runbook document is revised. After giving complete control over the automation process to the client, we arrive at the last stage of the implementation, which is project closure. Everyone from the automation implementation team and the client team is involved here. The implementation team confirms whether all services have been made as per the contract of agreement, and a handover process takes place for the management and the long-term support of the developed automations. For external implementations, the team checks and closes any financial loops. Following the client's review of these items, document handover occurs, and contract completion is signed off. With this, the automation project has been successfully implemented. Great! Now, before we conclude the video, let's have a quick recap. There are 8 stages in the UiPath Automation Implementation Methodology Model, starting with kickoff and ending with project closure. Each stage has a specific agenda to work on and expected outputs to meet. At each stage, the automation implementation team collaborates with the client team to deliver the expected outputs. In general, the implementation team consists of a solution architect, a project manager, business analysts, automation developers, and infrastructure engineers. Do you have extensive experience in automation implementations, or are you just starting? How could you become more efficient by using the information you just learned and the tools you just discovered? Thank you for watching, and until next time, happy automation implementation!